Right the cup, please. Yeah. Yeah, look at me, please. Okay, most people did a great job on getting through the homework. So one of those people who feel like they would like to discuss, test is on Wednesday. On the test, you take the test on time, you get 25 points free. So that literally means that the questions that are in this packet, there's 2 of them similar on the test. Those 2 questions are worth 21 of the 75 points you're going to be earning.
So the lowest I can get is 25%.
If you take the test, why give? Not that 25 points will help you. Because the grade is worth, test is worth 80% of your grade, so. But it does help to take it on time, because when you make mistakes, the amount that is deducted for each mistake is less. That's where it really helps. The 25 points that's free doesn't really help that much, Sarah. It's the deduction that helps. Okay. Is there a specific question they want to discuss? Today is reserved for discussing the gold packet. If you have anything you'd like to talk about on the gold packet, I'm glad to help. If you don't think of anything, we can move on to the practice test and discuss questions you may have from that. Please,
Let's go over number 4.
Number 4. Okay, no one talk now. Quiet. Okay, so question number 4 is again talking about a moving particle. Moving along the x-axis, so it's going back and forth. They give some information. They want to know, during the time interval 0 to 3, what is the greatest distance between the particle and the origin? And then we have to show the work that leads to the answer. So again, on FRQs, getting an answer is enough. You've got to show key elements. So it's a really good one to just kind of let yourself honestly stumble through it. What I mean by stumble through it is don't worry about like having the solution memorized or something. Just kind of think your way through it. So somebody pick up some tickets and just make a suggestion as to what I might write down. It's an FRQ, I gotta write stuff down. So what might I write down that sometimes gets points, sometimes doesn't, but always better to write more than less. Jeff?
Is it the part where like the grade, the minimum or maximum with credits being entered?
Yeah, I like that. 3 tickets. I want to add something to that. Somebody else tell me, I want to describe that the min or max is going to occur at a critical or end point. I want to describe what I'm referring to. Like, am I referring to where velocity has a maximum, acceleration, or position? Because that's what we're always talking about in these problems. So, talk to me.
So do you set like the equation for velocity equal to 0?
We will do that in a minute. 3 tickets for that. I just want to do something before that. No worries. I want to know what we're talking about. We're trying to find the max min of velocity, position, or acceleration. Position in this case. So, Sarah, what symbol do we want to use to represent the position in this problem? Perfect. X is a standard symbol for representing a particle moving back and forth. So I write that down. Let's see. X of t equals the position of particle. We have no equation for it. I just want to make sure I understand the symbol. 2 tickets for Sarah. Then I write Chad's comment. It says greatest distance between particle and origin. So let's see. X of t is greatest. Chad says to write greatest / least at a critical for endpoint of x of t. Cool. We just need to keep writing things. Amanda's idea was actually very good. Say again what you're thinking, Amanda.
So set the equation for velocity equal to 0.
Very good. So we always get points for doing that. So smart move. So let's say v of t is equal to 0 at, and we need to find that time. Somebody pick up 3 more points. Amanda got hers. Why are we doing this? Like, why are we doing this, Jared?
I have a
please.
question on, so like, I wrote down like the x-t is I wrote down the terms of the velocity. I said if you can find the distance from the velocity is equal to 0 or the endpoint, is that okay, or do I have to write it down in the terms of position?
Just say exactly what you said.
So like I wrote it down like you can find, basically I wrote it down you find critical points by velocity equals 0, right? And so I wrote it down instead of terms of position, I wrote it down in terms of velocity.
What do you mean by just read what you wrote?
So I wrote down the max slash min distance will be found when the velocity is equal to 0 or after that point.
That's fine.
So that's fine. I can write
Yeah,
that.
that's perfect. Why are we doing that? Like, why are we doing the thing with data?
Because velocity is the derivative of position. So when it's equal to 0, it means there will be a critical point of position.
Nicely said. 3 tickets for sure. The critical point on the position will be found when the velocity is equal to 0, or the velocity is undefined. So what's next? You guys are doing perfect. Go, Deborah.
So we find where the endpoints are.
Perfect. So what are the endpoints?
The endpoints are
Good. And what is the critical point?
it's to like project focus.
Nice. Now, you know, take notes.
Would you just put that next to the representation?
Right, so she put the velocity graph in her calculator, graphed that velocity, and then noted that right here is when the velocity is equal to 0. Okay? Everyone, eyes on me for just a second. Eyes on me. Look at me. Look at me. Don't do that. All right.
They're hers. Yeah, but
They're
oh,
actually-
jeez.
Look
You're
at
not mine.
Sorry.
That's all right. Hey, just a compliment to the class. Your questioning right now is really good. Look at me. Keep asking questions. Keep discussing. Look at me. Keep asking questions. Keep discussing. One of the things I'm most worried about is that when you take the test, you'll remember the basic ideas, but you'll get the symbols all mixed up because you won't have a good understanding of the big picture. So as we're discussing this, any little thing that doesn't feel 100% comfortable, just talk about it. And today's a really good day to get really, really good at the big picture because everyone pretty much got through the gold packet. So just making sure getting more and more solid is really going to make a huge difference on the test, I guarantee you. That'd be good to hear. So now what do you want to write? Go.
I did the derivative of different things after that. I mean, not derivative, I mean integral. But
So tell me what you wrote.
after
Because the key for FRQ is what you write, not what you think. So
yeah, so I wrote first. Well, I checked the both the endpoints with the integral. So I did like 0 to the end time, which is 3.
So you did an integral
Yeah.
from 0 to 3 of what?
V of t.
Did you remember to write dt?
Yeah.
Good. And just tell me what you write. Just tell me what you wrote.
Let's see. Sorry, I don't have that one. I don't have that.
Oh, no
one.
worries.
Right.
No worries. So 3 tickets for Chad, but just a caution again,
Yeah.
if you don't write it down, the grader can't assume anything. Sarah, please.
So is it correct to put, so I have everything to the blue,
Uh-huh.
then I'm thinking, like, I usually end up putting like V of 0 and then write that, and then V of B and then write that, and then V of the other endpoint.
Pause for 1 second. 3 points for Sarah. Be very careful here. I can't quite tell if you're writing something wrong or saying something wrong. What you said was this. Is that what you meant to say? Okay, so 3 more points, so that's 6 total, write them down. But we don't want to be finding velocities at this point. Somebody tell me why. Like, this really will lead to losing a lot on the test. We don't want to be doing this, Ellie. Right, so we're looking for when the position is furthest from the origin. So we don't really, I mean, we care about the velocity, but
Would the x is 0?
yeah, we want to find the position at 0. Be careful with that. I saw people last year on the test lose a lot of points for that exact reason. So 3 for Ellie. So somebody pick up on Sarah's line of reasoning and just, where do we go, Jackson?
I just had a quick question. For
Please.
every single one of these questions, do you want us to like put our own function in, like as x to t or whatever, for every single one, or is there only a few certain ones that need to do that?
Oh, gotcha. What you always want to do is, you do have to identify, okay, what is it that they want me finding the greatest of? Or what do they want me finding the least of? And we need some sort of symbol to represent what they're talking about. In this particular case, because it's position, you don't have to invent anything new. And you don't even really have to write what's in black. Because everyone, the grader knows that x of t represents position. But on other problems, you really do need to come up with a symbol. Otherwise, it makes it very difficult to communicate with the grader. Is that your question? No. 3 tickets. So what do we do from here?
So then, since x of 0, so up there, at time t equals 0, the particle is at position x equals 1, so it's not just x equals 1.
Perfect. 3 more tickets. I want to ask a question to somebody else, well, to the class. Somebody answer this. The whole goal of this problem is to find when the particle is furthest from the origin. I want to draw something just because in past years, people have really struggled with that idea of origin. So here's the particle moving. So I draw a graph like this, and I say, okay, origin has nothing to do with where the particle's position originates, even though the words are similar. Origin just always means location 0. So pay no attention to where the particle is. Origin means location 0. This means something different. Somebody else pick up 3 tickets and tell me, what does this mean on this picture? Sarah?
At time 0 is x equals 1. So
Very good. So I kind of come over here. So that's location 1. Here's my particle. That's when time is equal to 0. 3 tickets. Perfect. This is a graph of the velocity. Let's label that. Let's draw another graph just for future reference. Here's a graph of the position. I want to make sure you clearly understand that when I draw a graph of the position, you don't see the particle ever in this picture. Look at me. The particle is never represented here, ever. The particle's over here, moving back and forth. All this is a whole bunch of numbers. And the numbers tell us where the particle is over here. But this is not the particle. Some people will say, oh, here's how the particle moves, and they'll point at the graph of position. You don't see the particle here at all. The particle moves over here. You okay with that? So I only know one thing on this graph so far. Somebody tell me, what do I know on this graph at this point? Sarah's in for 3. Who else? Evan's.
At time 0, so 1.
Good. So I need to put a point at some horizontal, vertical coordinate. Where do I put it?
0, 1.
Nice. So go right here. So again, that's not the particle. That's just a dot, and that dot represents these 2 numbers. The 2 numbers tell us where the particle is. Perfect. Okay? Awesome. Okay, cool. I just want to keep going now. So what do you want to do now? Sarah's in for 3 more. Somebody follow her line of reasoning. Somebody else can pick up on what she's doing. Deborah.
So after you found x is 0, you don't want to find the x. So you want x.
Nicely done. Because this is one of the endpoints. Chad already established that the answer to the question is going to be either an endpoint of the position or a critical point of the position. And so at this point, just say it out loud, how far is the particle from the origin? 1. So Deborah says, let's go find out how far the particle is from the origin at the other time. So she says, x of 2.507. She already got 3 points. Somebody tell me what else to write to follow her thinking. Sarah's in for 3 more. It's the Sarah, Deborah, and Sarah show. So 3 more for Deborah, 3 more for Ellie. Let's go Ashley this time.
I'm just gonna do 1 plus, and then I'm gonna do 2.507.
And what do we write here, Ashley? Nicely done. 3 tickets. So do that work. So this is going to come out to be 1 plus. Need somebody to help me with the decimal there. Deborah's in, Annika's in, Chad, Sarah, Chance this time. Bailey, you're in 2, sorry. Wait, Chad.
Negative 3.265.
Negative 3.265. So now I get this number, negative 2.265. That's my position at time 2.507. So my distance from the origin at that time is 2.265. So the 2 choices so far, this is definitely when the particle is furthest from the origin. You guys are doing like outstanding on this problem. If you do this on the test, you'll get all the points. You write what we're writing, it's perfect.
So after, like, why don't you have to find the x?
We still do. Yeah, I was just, I'm sorry, just complimenting on that we've gotten this far perfectly. Perfect, 3 tickets. So somebody tell me what to write, Chad.
You do x of 3 is equal to, and then done that. And is equal to 1 plus, it's an integral, so 0 to 3 dt.
Nicely done, 3 points for Chad. So then that's gonna be 1 plus. Somebody have a number for me? Let's go out.
Negative 2.197.
This ends up being negative 1.197. All that's left to do now is just give a conclusion. You've got all the evidence you need, so you just say particle is furthest or farthest out of it? Farthest. They won't knock you if you mess up. Particle is farthest from the origin. Remember that commercial I heard on the radio? Particle is farthest from the origin at t equals 2.507, where distance from origin is, what was the number? Negative 2 point, yeah, don't really need the negative since I'm talking about a distance, but
Would they don't do that?
I don't think so. I don't know for certain, it's always best to be as correct as possible, but I think they do lean in on that.
What if you put T instead of writing?
Oh, that would be totally fine as long as you had told the grader that that's 100% valid. 3 tickets for Ellie and also Sarah. You follow my questions on that one. Perfect.
Do you have to say, because of distance, or would you have to say anything about how far the distance is at, x equals 0 and x equals 2?
Oh, well done. I don't think so. I think it's safe to assume that they understand that because you found the position at those different times, that you clearly understand that those positions are also indicating how far from the origin. I think you're saying so. Great question for tickets.
Do you have to say the distance from the origin, or can you just say that that's where it will be the
The question said, I'm not sure, hold on a second. What is the greatest distance between the
Oh,
particle
yeah.
and the origin? So I would use that wording instead of asking for it. Please, Ellie.
You have to solve it, but I don't think you know how far either way.
Ah, great question. 3 tickets. They just want to know how, what's the furthest from the origin. So they don't care right or left. Ashley.
for the 2.507, it's talking about the distance instead of time. So you have to-
Oh, thank you. 3 more tickets as well. No, actually, what happened was, I kind of started, I actually made a bit of a mistake. Didn't cost me anything. But I started kind of writing down the answer, and then I thought, wait a minute, are they asking for when the particle is furthest from the origin? Or are they asking for where? And that's when I kind of caught myself and said, oh, they didn't really ask for the time, but I didn't lie to the grader. I mean, I didn't tell him something that's incorrect, so I didn't worry about crossing it out. I just I just gotta add something.
So it doesn't matter if you do extra.
As long as it's not incorrect. Some people have this mistaken thought that, just laughing at Ellie and Barry, sorry. Some people have this mistaken thought that you can just write down a whole bunch of answers, give it to the grader, and basically, without saying anything, hope he picks the one that is correct. That's not valid. Like, you can't write down wrong answer, right answer, and make the grader do multiple choice. You won't do that. But in this case, we didn't write anything wrong, so good question. Anything else on this one? Anything else on a different one that you like would be useful to discuss in preparation for the test?
6 is kind of similar, but I want to make sure that.
Pretty good. The last discussion really was outstanding. We should just do the same thing. Just kind of working your way through, writing down things as you go. Just keep asking the exact same question you're asking. It's really good.
It's just because it doesn't have, it has like t is greater than 0. It doesn't give me like actual numbers to it.
Gotcha. So let me say back what I think you're concerned about. So Sarah noticed that in this problem, they say time starts at 0, so they do give a left endpoint, but they don't say when time ends. So time literally goes on forever, which makes it a little difficult to say go find an integral at that other endpoint. So a slightly different approach works a little better, but the beginning steps are really the same. So let's do the beginning steps, get them written down, and then I'll kind of show you what we can do slightly different. So what would someone like me to write first? Oh,
You'll find the highest point after there's an endpoint.
always. So let's write that down. And I want to, it's back to Jackson's comment, I want to write that down in terms of some symbol. Like I want to write it like, such and such is greatest or least. So what symbol, I need to get that down first. So I need somebody to help me. Ellie got 3. What symbol? Let's go chat this time.
Yeah, x of t be like position of the particle.
And we'll call it y in this case,
Yeah.
because they said the particle is actually moving up and down.
That actually, I have a question on that.
Uh-huh.
So like on mine, I did p of t. Would that be wrong? Or,
Did you write, just read what you
Or
wrote.
p of t is equal to the point of the particle at any given time.
The point of the particle or the position of the particle? No worries. Yeah, if you wrote, say it one more time, just say the word position.
Position of the particle at any given time.
That's fine. And you used P of T to represent that. Totally valid. Y of T is commonly used, but if you told the grader you're going to use P, you're great. Oh, what's that? I don't think they'll dock you for that one, even though it's up and down. So, and if you tell them that you're going to use that for the variable, they can't dock you. So, Y of T is the position of the particle. This is someone else. Hey, 3 for chat, 3 for different. Someone else, give me the key statement about the endpoints or whatever using the symbol Y of T. Just tell me what to write. David?
Y of t is greatest or least at an endpoint or critical point of y of t.
Perfect. 3 for Bailey. Be very cautious. How do I say this? The key thing is to make sure that all these problems really do make sense to you prior to the test. Then during the test, you will not get mixed up. You just won't. What happened last year and the year before is some people didn't take the time to make sense of this packet prior to the test. And then during the test, they started writing things that are a bit bizarre, to be honest. they wrote things like, they would say y of t is the position, but then they would say v of t is greatest at a critical or endpoint of v of t. And as soon as I read that, I'm like, why are we looking for when v of t is greatest? It's like they were remembering the process without any meaning. And
Wouldn't it be that like V of T, like the highest point of V of T occurs at the critical endpoints of Y of T? I think so V of T.
oh, hold on a second, I'll explain that. So let me get this written down first. So y of t is greatest at a critical or endpoint of y of t. And I want to write what you said, Annika, so I can answer the question better, even though no one else needs to write what I'm writing, just because it's not part of this problem. Say what you said.
Okay, yeah, so just the whole same thing except for I was thinking of V of T.
Oh, V of
So
t.
Just
Like-
at the end.
Over here.
Yeah.
Gotcha. 3 tickets. Here's your mistake. It's extremely common, no big deal. It all comes about because of this statement. Let me write this one down, Annika. Y of t has critical points where v of t is equal to 0 or undefined.
Oh, okay.
So the mix-up occurs, yeah, outstanding question. The mix-up occurs because no, anything is greatest where that specific thing has a critical or endpoint, but that thing has a critical or endpoint where that thing's derivative is equal to 0.
Okay, yeah, because we're gonna look at the other.
Yes. Yeah, that's why on the yellow memorized card I gave you, it has one line that specifically says, when trying to find the max or min of anything, make sure you are studying the derivative of that. Deborah, please.
Where did you get points? You have to write this things down. You would say V of t is 0 at time, you know.
Outstanding question. 3 tickets. So far, I've written these 3 things just to make sure that what we discuss in class makes sense to everybody. But on the actual test, none of this is required. Because y of t is a known symbol for position. This you have to know. This you also have to know, but you don't have to write it. Yeah.
So the only one that you write down is the
Not even the pink in this case, because y of t is defined as being a symbol that represents position.
So if you use a different one?
Different when you have to write it. Yeah, think of it this way, Sarah. If you're using, like Chad did, like P of t, and then later you start referencing P of t, and you never told the grader what P of t is, he can't give you any points. Please.
So the only, so like, could you just skip all those and then just write like V of t equals 0 at times?
Correct. So all of this can be skipped, but the first crucial thing you have to write is you do have to say V of t is equal to 0 at, and then give the time that you find. And this one I did last period, is it 0.443?
Yeah.
So, yeah, the blue is really the only required element so far. The purple, red, and green are not required. You've got to know those things, but they aren't required. Other than, like I said, if you're using a different symbol, you have to document it. Good questions. 3 tickets again for Sarah. So now what do you want to write? Sarah's in for 3 more. Who else knows? Deborah's in. It's Deborah, Sarah, Haley's turn this time. Good. Go ahead. Sorry.
Oh, that y of 0 over the 1.
Nicely done. So let's write that here. Perfect. More for Haley. Smell out. Sarah's in for 3 more. Just keep writing them down, sir. Good day. Annika's in for 3 more. Chad this time.
I would next do the integral at time 24.
Perfect. Chad, really want to emphasize that on FRQs, write equations so the grader can really follow what you're doing. So Chad's doing an integral, perfect, and I know he did this, but somebody else get the tickets. I want to say something equals something. Go, Lexi.
Y of 443 equals
That is what you want to do?
Yeah, you want to tell the grader what's going on. It's like you're communicating to him that, hey, I know exactly what I'm doing. One reason this really helps is because if you make a little mistake and everything else just looks perfect, he's much more likely to say, oh, this person really does understand everything. Well, there was no randomness about it. You can't just say this equals the integral, but we're close. The integral is definitely part of it.
One.
There we go, -1.
Yeah.
Go ahead.
Do we need to store like 4.3?
Absolutely. You don't have to declare to the grader that it is stored, but you have to make sure that when you use it in this computation, you're using the stored value. Any more from Taylor? Questions, anybody else? Please, Deborah. Oh, great comment. So if I probably misled you on that because I was trying really hard to get you to develop the habit of just always storing. You don't ever have to tell the grader that you store. The telling is really to just make life easier for all of you. It's like, oh, once I say this is B, then I can just use it here and not forget that it is. I apologize, I didn't mean to imply that it was required. The storing is required in the sense that you've got to make sure you're using the stored values when you're working on it.
But if you write in the equation, like more and more, that's not something that like you see stuff in the equation done early, you would have to
Yes, perfect, 3 for that. So if later down here, instead of writing .443, I want to just make my notes a little bit simpler, I can do this, Haley, because I have told the grader that it's B. It's back to what I was saying to Sarah Louder in the back, that if I don't tell him that that's B, and then I suddenly put a B right here, he's lost. He doesn't know what I'm talking about. So that's valid, you can do that, for sure. In fact, that's why I like doing it, Deborah, is because on the problems that are a little bit more complex, I just get tired of writing all the decimals. I can just write letters, and it just makes talking about it easier for me. So, outstanding today, really. This bodes very well for the test, I promise you. Like the things you're commenting on are just perfectly in line with what you have to do on the test. We need to write some more here. What do we write? Well, we kind of want some numbers, I think. So I've got y of b equals this stuff, so I need someone to help me since I wish I had the ability to do that integral in my class. Awesome, do 1 million computations in a second. Go, Brady.
No, I was just what the integral of it's like Ripple said.
Thank you, it's perfect. 3 tickets for Braden. Means we've got y of b is equal to, what's the combination here, Braden?
Negative 1.4047.
3 tickets, but that would be a big mistake on the test.
Oh,
Jackson.
It's -0.953.
There we go, 3 points for Jackson. Do you have any questions to hear? You're at the point where I told Sarah Parker that we do something different. Because finding an integral at infinity, we can't do that. So now what we realize is, let's draw a picture here. Particle's going up and down. The origin of the particle is, the origin is always location 0. Particle begins its journey at location -1. So here's location -1. This is the particle. This is time equals 0. Because the velocity is positive initially, the particle goes up. And then the velocity is negative, so the particle goes back down. When does the particle reach its highest point? It appears to be here, but I need some sort of justification for that. So we need to just write a little bit more. All I have to write now is this. I've shown the position at one end point, I've shown the position at the other critical point. All I say is for times, like all time greater than time b, which is 0.443. So for all time greater than this, b of t is negative. So b of t is negative for all of that time. Therefore, the position of the particle is increasing or decreasing for all time after that. Decreasing. That the position is decreasing, that means the particle is going down. So, let's see, you want the time or the height? Find the time. So, particle is at highest point at t equal 0.443. Please.
Could you use could you draw a picture of the graph and use that in your explanation, or is that not allowed?
Depends. So just tell me exactly what you're thinking. I'll tell
Because
you.
on this problem, just based off the graph, you can tell.
Graph of what?
The graph of velocity.
So let's label that. Hold on a second. This is V of t. Keep talking.
So with the graph, you can tell where the maximum point is, because I don't really want to say it, but because it goes up to a certain point and then it will never go up after that, which is at the point we found 0.443. And so could you I feel like on this you can almost label the graph and then explain based on the without doing it. And I don't know if that's legal or not, but
Gotcha. 3 tickets, outstanding comment. So here's what you can do. We already talked about how the pink, red, and green are required to be known, like you have to know those things, but you don't have to write them down. The blue will get you points. You need to write the blue down. Everybody look at the board, everybody. Okay, after the blue, Chad is 100% correct. In this particular problem, and this will happen again in other problems, you can skip doing everything below the blue. Like at this point, you don't have to do any of this if you don't want to. You can do something else instead. Let me write down exactly what you can do instead. So instead of all of that, let's document it this way. So you can do all of, what do we say? I just want to write this in such a way that if somebody looks on my website, they can kind of follow what we did here. So we have to go to that point, and then, I don't know, it's hard to say. You can either do all of this stuff here, or instead of doing that, you can write the following. So, or do this instead. You basically say what you have to document what you're thinking though.
Yeah.
And the best way to document it is this. For time 0 up to time 0.443, 444 would be wrong, 443, B of t is positive or negative? Say it. So B of t is positive. So what's the position doing during that time? So y of t is increasing. So I write that. Then you write for all time after that, 0.443, B of t is negative. So y of t is decreasing. You're there?
Yeah.
Therefore, y of t is greatest at t equals 0.443, and that also gives you full credit.
But
Is
you
that-
wouldn't need to draw a graph.
You don't have to draw a picture. If you draw it, it doesn't hurt anything. Please.
Oh, I didn't, it's not applying, I didn't do the greater or less than sign. All I wrote, I did the V of t equals 0 at t equals 1.443.
I mean, hold on a second, Ellie, you just got to trace what you're doing. I don't want to
I wrote
say.
the blue.
Good, so you have this.
Yeah, and then I just explained that at t equals 0.443, it is the only critical point, and it's going from increasing to decreasing.
Okay, hold on a second. Ellie gets 5 points for this. Your thinking is really good. I'm a little concerned that they won't give you all the points for it. So I would like everyone to write the following, like everyone write this on your test. Write the following on your test. Because I want to illustrate an idea that will lose you points, if you'll lose points for this, so that once you see it written, you go, oh, okay, I understand the difference, now I won't do that. Because your thinking is 100% logical. It's just that they require one more thing than you said. So this isn't exactly what Ellie said, but it's similar. And it's a common thing that people will write, and they will lose points for it. So make a little note, don't write just the following, or you will lose points. So here's an example of a logical comment that just isn't enough. So you're not losing points for saying something wrong, you're just losing points because you didn't say enough. I write this, at t equal 0.443, V of t, sorry. V of t changes from positive to negative, you can abbreviate, positive to negative. So at t equal 0.443, y of t changes from increasing to decreasing. Therefore, y of t is greatest at, and that's where I'm lying now. All I really know from the blue is I know that y of t has what's called a relative max at that point, but it doesn't necessarily mean that y of t has an absolute max. So I know we know that it does, I get that. When you're trying to convey information to the grader, he's going to read these words and he's going to say, no. You correctly documented and justified the location of a relative max, but you did not correctly document and justify the location of the absolute max. Therefore, you're not going to get points for this. The key thing, one second, the key thing is that when they're looking for absolute max, you must do what Chad said earlier. You have to account for all time. So this is focused on one moment in time, not good enough for an absolute max problem. You must account for all time starting at 0 and going to wherever they say time stops. So in this case, because time went from 0 to infinity, we had to write Chad's comments in green, sorry, not green, right here, green. We had to do the green comments because that accounts for all time, versus the blue comment is only one moment in time. Talk to Devin.
Oh, I was just saying, but if you add this into the slide, and then it continues to.
Oh, then you'd have to do two things. You'd have to say, again, it's back to that idea of saying, well, from time 0 until time 0.443, You've got to do something to account for all time. All time, not just one moment in time. You've got to explain what's happening from time 0 to this time, and then from this time to this time. No, I'm not sure that helped.
No, that did,
Okay.
but I was wondering, instead of writing, like, the stuff in green with the greater or equal sign, could you just simply write it out from 0
Yeah, that's
to
okay.
1.43?
Oh, yes,
And
yes.
then from there on, it's like.
Oh, absolutely, absolutely. Hey, look up. Yeah, that's just a matter of notation, and either way is fine. So I won't write it out because it would take a bit, but you can say for time equals 0 until time equal 0.443, V of t is positive. See, now you're accounting for all time. V of t is positive, so y of t is increasing. Then for, like Deborah said, for all time after that, V of t is negative, so y of t will decrease forevermore. Therefore, y of t must be greatest at time equal. That's perfectly
And you don't
fine.
have to explain because, like, it's a critical point.
You don't.
Okay.
They basically looked up here, and as soon as they saw the statement in blue, they made the assumption that you knew the statement in green. Like, they just assumed that if you're writing this, you know why you're writing it. Sarah, please, these are outstanding questions
So,
today.
what's the difference between, like, saying justify your answer and then show the analysis that leads you to? Can you, for the conclusion and the one that the second part that I just read, do I have to write, like, a whole bunch of stuff, or can I just answer the question directly?
Yeah, that's a tough question to answer. When they say justify, I know that I've got to have some of these patterns that I've been showing you. Show your work sometimes really does mean just show your work. You don't have to have extra things. What I'll keep doing, Sarah, that's one reason why I reserve a lot of time for just practicing the test, is I'll just kind of keep showing you what you need, what you don't need, and it just varies from problem to problem. But with really just a little bit of practice, you'll be fine. But I don't have a straightforward answer for you, so. Derek?
Okay, so, I probably know the answer to this, but I just want to ask, so like, I didn't write down like V of t equals 0 at time, like 4.3, but I wrote down like, the change of position can be found where the particle's velocity equals 0 or at endpoints, and then I just wrote down the values. Do I need to specify that?
I know that was okay, because you said the same thing in words.
But I didn't specify that 0.443 was found as a critical point and not an endpoint.
Oh.
You know what I'm saying?
Yes,
Like,
it
I just
probably
said-
would be better.
I said possible high points are at t equals 0 or 0.443. Like, so the possibility. So
Gotcha.
do I need to specify that the 0 is an endpoint and the 0.443 was a critical point?
Oh, no, I got you. No, I
You know
got
what I'm
you.
saying? Or
I
does it
think
not
you're still
matter?
safe. The blue is safest.
Yeah.
Because it matches exactly what you see them indicating in their scoring guidelines. But I think you'd be fine with what you wrote.
So I don't need to specify if it's an endpoint or a critical point?
No, that they.
As long as I have the right points.
Yes.
Okay.
Yeah, that's very good. I'm sorry, I misunderstood. Yeah, you don't have to say this is an endpoint because they pretty much know that you understand that the endpoints are here and here. They just want to make sure you're not forgetting them.
Yeah.
I have seen points deducted when people didn't make any reference to the endpoints. So, yeah, Chance, please.
I just have a question on what I wrote. Like,
Please.
well, I wrote after t equals 0.443, the graph of v is negative, therefore the particle's height only decreases after t equals 0.443.
That's perfect. Did you have anything talking about what happened from 0 to 0.44?
No, I mentioned that later. I mentioned that before I even did the analysis for like
genius.
y of 0 or anything.
No
like that.
worries. So you wrote that. That is perfect. And what did you write after that?
Afterwards, so I just did my calculations for p of 0, and then, because I used p of t for my particle position, and then I did my p of a for p of 0.443, and then afterwards I wrote, therefore the particle is highest at t equals 0.443 because p of 0 is less than 0.953, and after t equals 0.443 the particle's height decreases.
Yeah, you're fine. It's beautiful. Yeah, you can tell from all of that. Did you have something about this somewhere?
Yeah, I did.
Yeah, you're great. Yeah, no, that really perfect. The grader's going to look at that, and everything he reads just makes consistent. It makes sense. It's covering the requirement, like I said to Sarah. Really, Sarah, that's just remember that requirement. Whether they say show your work or justify your answer, if they're looking for an absolute max or absolute minimum, where something is greatest or least, you have to account for all time. Endpoints and critical points. As long as you do that, like how Chance did, it's perfect.
What if you just do that all the time?
What do you mean by all the time restriction?
Like you may have to say absolute maximum in the question.
Oh, you have to be a little careful. When you say all the time, I guess lots of other problems wouldn't even be similar, they'd be totally different, I guess, that's why I say all the
Well,
time.
because the way that I'm like viewing these problems, like the steps in my head is to just like do the first 3 ones, because those kind of apply to the majority of them, and then I just do the y of 0, and then the y of that, and then the y like of the endpoints.
Let me say something back to you. I think you and I are on the same page. Everything in this packet deals with finding what something's greatest or least.
Okay.
So yes, for this style of problem, you're safe to just do that. What I was trying to prevent you from doing is this. If the problem, which there isn't any in this packet, but on the test you might see one. If the problem simply wants to know where some function has a relative max, you don't want to mess around with endpoints or anything like that. Relative max can be justified very easily by doing what we were writing in green. Sorry, in blue. Like what's written in blue, that's a proper justification. So I want to cross this out because this isn't true. But I want to finish what I had started writing because it kind of answers your question. So the blue here, so v of t changes, so therefore y of t has a relative max at t equal 0.443. That's a valid way to justify, this is a, come on, red pen. This is a valid justification for relative max. But not absolute max. Shoot, I have this bad habit. That twice today. I'm making too many desserts. Please.
Okay, so I have 2 probably pointless questions, but, so would there ever be a time where, well, kind of go there, where like, they don't give you, like, at time equals 0, they won't give you a value, and then just like, or will there be a time where like, let's say, so it's like 0, let's just say the last one was like 0 to 3, right? Will they ever give you like the value at the 3, and you like have to work backwards, I guess? Does that make sense? So there will be where like you don't have like the starting, you have the end point, and you kind of have to like integrate, not backwards, but you have to do the like subtracting. Okay, but they'll always give us like a value either at the beginning or at the end.
Or somewhere in the middle.
Or somewhere in the middle. Okay.
Yeah, the idea is this. Brief and direct, outstanding question.
And if they don't, is it 0 or they always specify?
So let me answer now. Outstanding, 3 tickets. It all goes back to the fact that when you integrate velocity, you don't find position. You find how much the position has been changed. And so knowing how much the position has been changed, combined with the knowledge of at least one position anywhere, beginning, end, middle, those 2 things together can find you any other position.
Okay.
So yes, there have been many AP problems where they give the position at some other time rather than the beginning.
Okay.
For sure. There have even been AP problems, listen, where they don't ever give you the position, but they create a question so that you don't need it. I can't remember exactly the details, but the question is more about how is the particle's position changing than it is about where the particle actually ever is.
Okay.
Does that make any sense? Okay. Sarah, did I answer your question? Okay. What do you have? Really well done. Other problem from the packet that, I'm not kidding, the discussion today has been like, this is like the best discussion I've had in months. Sarah.
So on the answers for 8 and 9, it has like charts. Is that the same as having integrals?
Yes. Yeah, really good observation, Sarah. They just put the information that you found from the integrals in a table. You don't have to make a table.
Okay.
And you'll notice as we do more and more FRQs, that the scoring guidelines are guidelines, so they try to give lots of different examples. So one time they'll put it in a table, then the very next problem you'll see them just do a list of integrals. Folks have a problem with the packet you would like to discuss? Haley,
So
please.
this is just kind of on scoring, so on number 2, you have to find like the minimum value, and you could have just found it from the graph, but I did it in my equation and my integrals. And then on number 3, it asks like what the number is, and so since on number 2, I had already found it, I just used the information from that. So would I have to rewrite everything that I had found for the?
No, outstanding question. 3 for Bailey. This is, you don't care, actually. Hey, look up. Look up. Okay, no, crucial question, but well stated. Okay, look at my notebook. Look at my notebook. Look up for a second. This is Deborah's, by the way. When you take the actual AP test and you're in the FRQ section, you're going to have a booklet. Of course, it won't be thick like this, but it's formatted like this, okay? And you'll open up the page like this, and there will be a, how would you say, problem description, like the one you see here, okay? And then following that description, the description will be right here. Following that description will be part A, B, C, and D, and they don't repeat the description. The description is only at the very beginning. But the rule of the test is that anything written on these entire 2 pages can be used anywhere else without having to rewrite it. So as Bailey said, when she worked problem 2, she chose to find some integrals and such, and she needed that integrals value when she got to part C. You don't have to rewrite it. You can just reference, I don't know, you can either reference it or just rewrite it again. She doesn't show how you found it. Is that your question? Yes. Perfect. Jackson?
How many FRQs are on the final test?
The test? So, looking at this notebook again, it's the best way to describe it. There are 6 of these. So 6 sections like this where you have a double page, and it has a problem statement and then A, B, C, D. Most problems go A, B, C, D. Going A, B, C is fairly common as well. Really rare to just go A and B, and I've never seen one that was just A.
So on the 25 question.
Not yet, sorry. So you have, yeah, you got it. Yeah, you got it. My bad. Sorry. So there's 6 of these, right? 6 times 4 would be 24. So usually between 20 and 24 questions. In reality, a bit more than that, because you'll notice that sometimes the FRQ asks a couple of things. But that gives you an idea of that. Let's go there first.
So like you said, like if it's like a problem where I have like 4 different parts, that's 4 different things in one situation. Let's say like on the last part, let's say like I forgot something in like part A, but I put it in part B. Do I still get the point in part A, or is it like only going forward?
Oh, gotcha.
You get what I mean? So they go backwards too. Like if I forgot to write down B of T equals 0 at a certain point, but I do it in part B, but I did part A, do I get the point in part A still, or?
I've never seen them structure an FRQ that way. Okay, so it's never come up. So I don't think it will come up. In fact, most FRQs don't truly, like they do build, but they don't. Like this one did, like it was helpful.
You did it in a certain way.
In a certain way, and but most of it, they're related to the same situation, but they're different questions.
Okay.
Sarah?
Are all the tests timed?
Okay, listen, hey. Okay, I want to see you looking at me again. I want to make a little analogy. The analogy really, I hope, will help give you some comfort about the whole timing, like make you feel at ease. Okay, please answer this question. I'll pay you for raising your hand. How many people, free tickets, that was clever. Okay, how many of you at some point in your life took the ACT, listen, and as soon as you walked out from taking the ACT, you thought to yourself, dang it, if they would have just given me a little more time in certain sections, or maybe every section, I know for certain I would have done better. Show me your hand. Because they
I've
give you-
experienced that.
Okay, tickets come over, 3 tickets. It's very common. I've done that over and over again in many, many classes, and the response is always like 95% of the room raises their hand and says, yeah, if I had more time on the ACT, I am certain I would have done better. The timing is part of the ACT test. Hey, look at me. Hey, when students leave the AP test, they don't ever say that. Okay, listen, they don't ever say that. The test is timed, Sarah, but they don't ever say that. They say things like, oh, the non-calculator section for multiple choice was just brutal. They just kept asking these questions, like, that is so far out there, it's like so different than what we practice. They say that. They say like it was really hard. But usually their reaction is, I went through, I did all the ones I could, so how did you do? Like, well, I think I got about half of them. Like, okay, remember, half of them right is a 4. Oh, that's right. So you did better than you thought, you know? Okay?
That's crazy.
But they don't, what happens is they do everything they can, and then they kind of try to attack the ones they think they might be able to, and then they still have some time left, and they're just like, I don't even know where to start, you know, like, and they try, but, so timing just has never been an issue. The first year I gave the test, I had a student who I was really worried about, because, man, when he would take my test, he was very, let's just say, deliberate. Okay, I don't want to say slow, that sounds like a derogatory comment. Like, he just would take a long time. I thought, man, the timing's going to kill you on the AP test. He got a 4. Okay? Same thing the next year. Another kid, his parents tried to petition the college board to give him extra time, and they were not successful, so they were very worried that he just does things not as quick as everybody else. He got a 4. Okay? So no one ever says that time is the problem.
If you mark an answer and it's wrong, like, do you want to leave it blank if you don't know it, or do you want to?
Great question. When you're doing the multiple choice test, and we will practice doing this, the strategy you want to use is, first you keep reminding yourself, I get the same number of points for answering an easy question as a hard one. So no reason to spend time doing hard things first. For sure not, okay? So you don't do the test in order. Like, you start, you keep going, right? But as soon as you hit difficult, you just go on. My advice, just like kind of scan the problem, go, I don't know what that means. Flip the page. Next problem. Oh, I know how to do this. Do it. You know what I mean? I go through the test. I would go through the test 3 times. First time, just getting the things I can do quickly and for sure and get those done. Second time through, I'm doing the problems where I'm like, pretty sure I can do that. It just feels like it's going to take longer. So do that second. Third time through, I'm just trying to get done what I can on the hard ones that are left, okay? As much as I can. Always keeping track of the time. So I would always take the test. You can't use a digital watch because they're too capable. I just go buy me a $5 watch, and I'm keeping track of the time always. Like how much time, you know, just kind of keep an eye on it. With like 3 minutes to go, I just guess on what's left. There's no penalty for guessing. It's just like the ACT. You do not want to leave multiple choice bubbles blank. Okay? Len had a question.
Oh, so they don't let you use digital watches like at all?
No, because it's too easy to cheat nowadays, right? So yeah, you could literally link up with somebody outside the room. And, so it's got to be either, it could be a digital watch that's just old-fashioned digital. But like when I looked at Tyson, I was going to say, bring a watch. And I'm like, I don't bring a smartwatch. So the time. I'm not the person in charge of the test. We'll have to double check the rules. They didn't say anything. You should be okay.
Yeah, I feel like screw with it.
Oh, really?
Yeah.
Oh, yeah, the ACT data.
Take off your
That
hat.
chance, please.
Like any analog watch.
Analog. Yeah, for the, anyway. We good? Follow-up questions on that? Really, look at me, look at me. We practice the AP test to the point where I feel safe in telling you that I can pretty much predict to about 98% accuracy about how well you'll perform. Okay? Which, no, Braden, really, look at me, that's good news.
That's
Look at
good,
me.
okay.
No, listen to me, this is a good thing. Because that meant, really, the only ones who, I told you, 87% of those who took it passed. And 75% of those who passed got a 4 or 5. And it wasn't borderline, it was like they killed it. I look back at the data, and really only a very small percentage. There's always surprises. Somebody doesn't feel well that day. I don't know. There's just always a couple of surprises both ways. Somebody does better than you think they might. Somebody doesn't do quite as well as you hope. But really, overall, 252 students and a handful were like, oh, it didn't quite work out how we expected. You know, everyone else pretty much what we expected.
When you like guessing, do you have a
Oh, letter that I like best?
Yeah.
I don't. And I think they're pretty smart in that they have statistically made sure that doesn't really happen. So if it were me, I would, the odds I would play is I just pick one letter, just mark them all.
Yeah.
Yeah, to me, you're safer to just pick one rather than, I think I'll try to outguess it. You know, this one feels like A, this one feels like B.
I do that every time. That's what I do. Like I try and analyze the pattern like before. Like they're not gonna have 4 C's in a row.
They have them.
So what I'll always do is I'll be like,
Yeah,
oh,
yeah.
are
No,
there
there's
doubles
a
on this
real,
list, triples, quadruples?
we'll do lots of practice tests so you can start to see what they've done. But yeah, there was one you're like, I swear, 5 in a row. It was really cool.
Like that can't be right.
Yeah, honestly.
I must confess. We gave a quiz once in class. It was a multiple choice quiz. And the quiz didn't really count that much, so I was just doing a little social experiment. And I made it so that there were 8 questions and every answer was C.
In a row.
Only 8 questions, every answer, just to see who would pick.
Mr. Nair did that to me last year.
Sure. Wait a minute. Anyway, so hey, no, I've structured the class so that we have enough time to do legitimately like some serious practice testing. So when you, like I said to Sarah, no one ever leaves the test and says, I wish I had more time. But I felt very good about the fact that I've had people come up to me and say, we really were prepared. Like, they're gonna fool you because they always come up with new questions and things, you know what I mean? And like last year, I remember like people saying, oh, the non-calculator was brutal, but my gosh, the calculator, I like sat there for 20 minutes because I was done. Like, how did you get right? I swear I got every one of them right. Like, the test just kind of varies from year to year. But you will be prepared. Like if you, hey, listen to me, hey. I promise you at the beginning of the year that if you will follow me, like you'll stay up on your homework, you'll do what you did today, like you'll ask really good questions in class and such. You'll always make sense of the ideas. You'll be just fine. You really will. Okay? You just will be just fine. So when I said the brain is a good thing that I can predict because 75% got a 4 or 5. Okay? So, it worked.